want to take a catch. Alright, so still you want to take risk? Okay, but you can take apple home. Okay, so you still want to take the risk? Okay, alright. You take it home. Number 1. Y equal to, okay, so first, okay, here is the grocery list, the agenda. There are 5 ways to take the derivative. You already learned the first way. What is the first way? Using definition of derivative. Okay. So the first way is using definition of derivative. The second way, using the power rule. The third way, using the product rule. The fourth way, power rule, product rule, quotient rule. Quotient rule. And the fifth way, chain rule. Okay. This is the calculus 1. And the calculus 2, or the last part of last few days of calculus 1, which is integration. Calculus 2. Calculus 2, okay, which is integration. Or just last few days of calculus 1, because you're going to touch integration anyway. Anti-power rule. Anti-power rule. So I'm going to give you this background to challenge you, to accomplish something. Last time I made your life easy. I gave you a job to be a cop, to verify whether I broke the law or not, and you did a good job. Why you did a good job? Because I made your life easy. How did I make your life easy? Can someone explain that? How did I make your life easy? I gave you a problem. One day, Professor Barry went out to 1.5 hour long bike trip, and within 20 miles of the trip, he saw a speed limit sign, 25 miles per hour, and his position function was 40/3t squared. Did he break the law? What piece of the information made your life easy?
Position function.
Position function, very good, very good. Very good. Position function made your life easy. 40/3t squared. Today I will not give you position function. I have an apple. I'll give you apple, and you gave me position function. So, using this background, okay. So, finding position function. So that would be your challenge today. Once you find the position function, we'll discuss for the day. Okay, so let's get started. Starting using definition of derivative. We're going to solve a problem using that. So we already solved y equal to x squared. Now we can solve something different. Y equal to, so number 1. So y equal to say x squared plus what? Can someone give me something? Huh? X squared plus 3? Okay, x squared plus 3. First thing, what are you going to do? You're going to change y to the f of x. X squared plus 3. Okay. And then, well, this is not exciting because the derivative of this one and the derivative of other one is same. Can you give me another variable? X, okay. Just to make it interesting. It's more interesting now because this derivative and the one this derivative is different. Okay. All right. So now what are you going to do? F prime of x is equal to limit as h goes to 0, f of x plus h minus f of x over h. So this is a machine, you have to use it. This is called the Definition of derivative. This is called definition of. This is called the definition of derivative. Okay. So now f prime of x is equal to limit as h goes to 0. You see this one, right? So this one would replace by x plus h square, right? And then what are you going to write? Plus x plus h. And then what are you going to write? Minus x square plus x. Does that make sense?
Isn't it? F of x at the beginning, f plus x plus x.
So this one was replaced by x plus h. Does that make sense?
Yeah.
And the power is here. This one was replaced by x plus h.
Okay.
And the power is
1.
so 1. Minus f of x. What is the f of x? F of x is x square plus x. So you put this in parentheses, otherwise you probably make mistake distributing negative sign. Does that make sense? Okay. Everything over h. So f prime of x is equal to limit h goes to 0. Now we're going to use that again. That formula, you either memorize it or you understand. If you want to derive it, it's going to take too long. You're just going to write it down. X square plus 2xh plus h square plus x plus h minus. Be careful. Minus, what are you going to write? X squared plus x or minus x? Minus x. Be very careful. H. So f prime of x is equal to limit as h goes to 0. Something cancel. If nothing cancel, then you did some mistake. So x square cancel. X cancel. And you left with h, and that makes you happy, because that's what it should be. So what do you want to write? 2xh plus h square plus h over h. So f prime of x is equal to limit as h goes to 0. So what are you going to factor out? H. So you factor out h, then what are you left with?
Plus
H
plus 1.
over h. Cancel h.
Okay.
Take that h to 0.
Yeah, 2x plus 1.
2x plus 1.
Okay, what I should do now?
Take the h to 0.
And then what should I write?
And f of x.
Everybody should say that, not just one person.
2x plus 1.
F prime of x. F prime of x.
2x plus 1.
2x plus 1. And that's the answer. Okay, raise hand if you understood this. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's fine. That's fine. 9 to 10. That's fine. I mean, you know, this is. Okay, that's fine. We're gonna be doing this like many days. Okay. Without spending more time, please understand that we're gonna be spending over 2 months to doing this type of thing. Okay? So we know, yes.
Can you explain how you got x plus h squared?
X plus, okay, line, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. To make my life easier. What?
Line 4.
Line 4. Line 4 where?
X plus h squared.
X plus h square. Where did I get it? Okay. So the function is x square plus x, right?
Yes.
X1 to be more precise. Now x is the variable, right?
Yes.
This has to be replaced by x plus h, right? So you don't even have to, this is like a bluff. You can write it like that, blank square and blank raised to 1, right? That blank will be replaced by something else. And what is that something? X plus h.
Got it.
Okay, great. Any question before we move on to something else? No question. Okay, great. By the way, power rule, you are not even allowed to use the power rule next 1 month. So I'm just showing you power rule, just giving you background to do something important. So power rule is something that you even don't need to know for a long time. Okay, here is the power rule. Number 2 is power rule. Power rule. So power rule allow us to what? Do what? Allow us to take the derivative. Okay. All right. So we're gonna use the same example just to show you that the answer should be same. So y is equal to x squared plus x, right? Now the power rule tells us, here is the power rule telling y is equal to xn. Okay, write that down. This is the machine. So y is equal to x raised to n. Right. Y prime is equal to, bring the n down, make the n coefficient. So n, x, n minus 1. So this is the machine, and that machine allows us to take the derivative using the power rule. Does that make sense, what I did here?
Yeah.
Okay, great. We're going to do that using the same problem. Now we're going to write y prime. Instead of writing, when you do the power rule, instead of writing f prime of x, we are allowed to write y prime, and that's often the case. So y prime is equal to, what is our power? 2. We should bring it down, right?
Yeah.
2x 2 minus 1. And we want to be very careful. We want to write 1 here. Make our life easy. So we're going to bring 1, and then we're going to write x, and then what? 1 minus 1. That is fine. That's completely fine. So y prime is what? 2x
plus
1 plus x 0. Okay, y prime is 2x, and anything raised to 0 by definition is 1. So this is our answer. And as you can see, that the answers are same.
That's the derivative?
Say that again?
What does it?
That's the derivative using power.
Using the power.
Using the power. The other one was derivative using the.
The limit.
So I'm giving you everything at the same time so that you will be less confused.
Wouldn't that make it like faster than using definition?
But this doesn't give you any understanding of what is going on inside and why it is so powerful and how you can be scientist if you don't see the nitty-gritty of what's going on inside. Why derivative is so powerful concept, you don't see that here. This is when you already know what's going on, and then you find the shortcut. Does that make sense? Okay. When you use the calculator, when you already know how to do addition, division, multiplication, and subtraction, before you learn that, you should not even using calculator, right? So this is a shortcut. Okay.
Okay.
Power rule. How many of you understood the power rule? Raise hand. Okay. Great. So this is easy way, but we're not going to use that.
Professor,
Yeah.
I have one question. Why you have that one line 2?
Line 2.
Yeah, line 2, you have 2x to the 2 minus 1 plus 1 times x 1 minus 1.
Why I have 1?
The 1.
This one?
Yes.
I have to bring n to the left.
Yeah, I know.
So if I have to bring the power to the, I have to make the power to coefficient. So I make the power to the coefficient first.
But it's not necessary to be there.
You want to show this that?
No, you just demonstrate for the demonstration. Oh,
Yeah.
okay.
Yeah.
So, no,
Yeah.
that's what I'm saying.
To be consistent with the formula that I put up,
All right.
just to be consistent.
Okay.
Once you get the hang of it, you don't have to do all of, you just gonna do it in one step. Okay.
So you bring the coefficient, you bring the power down, it becomes the coefficient,
Right.
and you reduce the exponent.
Right. Okay, now we're gonna do product rule. So the product rule is product rule. So product of two numbers. So y is equal to x plus 1, x minus 1. So y equal to x plus 1, x minus 1. So this is the formula I want you to memorize, so I want you to write it down, not the formula in the book. So you're gonna call this is first and this is second. So the product rule is y prime is equal to derivative of first times second plus derivative of second times first. So the power rule is hidden inside the product rule. Without knowing the power rule, you cannot do the product rule. So derivative of first, because this is the first product, this is the second product. Derivative of first times second plus derivative of second times first. That's how you read it. Can someone read it for me? This is statement.
Derivative of
No.
Y
Yeah.
prime equals derivative of
First times
times the derivative of the second plus the derivative of
the second times the class.
Yeah.
the derivative of the second times f or the first.
First, yes. Yeah. Okay. All right. So we're gonna put this the formula in action. So y prime. Can someone tell me the derivative of first, since you already know the power rule hopefully?
x plus 1.
What is the derivative of x?
1.
1. And what is the derivative of 1? By definition, derivative of 1 is
0.
0. Right? So 1 plus 0. Does that make sense?
No, I see.
Oh yeah, I get it.
Derivative of, okay, so y is equal to x. What is the derivative of x? Being done 1, x 1 minus 1. So y prime is x 0, so y prime is 1. We understand that, right? Now, by definition, the derivative of constant is 0. If y is 100, y prime is 0. If y is 1, y prime is 0. If y is 1 million, then y is 1 million, y prime is 0. What about 1 trillion? 0. Okay, that's by definition. By definition, derivative of constant is always 0. Is this a constant? Yes, a number. So if there is no variable next to it, then it is constant, and by definition, derivative of constant is 0. So what is the derivative of x? 1. Plus, what is the derivative of 1? 0. Okay, we did the f prime part, right? The first derivative of first, right? Now we're going to do the second. We're just going to write the second, right? We're just going to write the second. And what is the second? X minus 1. Does that make sense? And now we're going to follow this. We're going to write x. No, we're going to write plus. Now we're going to take the derivative of second. What is the derivative of x? 1. What is the derivative of 1? 0. Then what are we going to do? We follow the order. First, x plus 1. So we are following the rules, we are following the order, or we are following the, I don't know, recipe or whatever you call it. Does that make sense from here to here?
Yeah.
Now we're going to simplify it. Y prime is equal to 1 plus 0 is x minus 1 plus 1 minus 0 is 1, x plus 1. We're going to simplify more. If you distribute, then what do you get? X minus 1 plus x plus 1. So y prime is 2x. Okay? Alright. So at home you're gonna try, here's what you're gonna try. You're gonna do it by power rule. How are you gonna make this problem power rule? By foiling it. Multiply this one, this one. If you multiply this one, what do you get? Y equal to x squared minus x plus x minus 1. So what do you get? Y equal to x squared minus 1. So you're gonna do it by power rule at home. No. Okay. Y equal to x squared minus 1. So right next to here that, not homework. Something that remind me to do it on Monday, Wednesday. Y equal to x squared minus 1. Y equal to x squared minus 1 is equivalent statement of what? Is equal to what? X plus 1? X minus? Does that make sense? This one and this one is same. Does that make sense? If this derivative is 2x, this derivative, if this derivative is 2x, what is the derivative of this one? 2x. Just do different way. Yes.
So with the product rule, we got y prime is 2x. But with the power rule, we got y prime is 2x plus 1. Isn't there a difference, or does not plus 1 doesn't matter?
We use different examples.
No, we use the same, x squared plus
Use the same.
x squared plus x. Isn't that what you just did?
No.
Or am I did it?
No, he used x plus 1.
Isn't that when you do the term?
No, it's not.
What is it?
This one, x squared minus 1.
Okay.
It's not same thing. This is not same thing. Yeah. Okay. Okay. So can we move to the quotient rule? Quotient is, what is the quotient? What is quotient? When someone tells you about quotient, when division, right. Quotient means division.
So Professor,
Yes.
you said it's impossible to employ the product rule without using the power.
Yes. That's right. You know, you need to know power rule to do the product rule, quotient rule, and chain rule. Everything is hidden. In the quotient rule, chain rule, and the product rule, the power rule is hidden. So you must know power rule. And why wouldn't you? Because power rule is so easy. X raised to n is equal to n x n minus 1. So that's all you need to know. Okay, great. Now we're going to do the quotient rule. Quotient rule, just to let you know, quotient rule is P over Q. Q cannot be 0. So this is a quotient. Well, this is the definition of. That's the big definition of being quotient. Okay. Now we want to make a problem look like that. That's what it is. So y is equal to, say, before we had x plus 1, x minus 1. Let's say, I don't know, something x squared on the top, and x squared on the top, and x plus 1 on the bottom, x plus 1 on the bottom.
Oh, come on.
Say it again?
Take a long one.
Huh?
Like, take a long one so you can, I mean, a long expression so you can do it. Like x cube plus.
The simple ones is
Okay. So what are you going to do now? So let's derive the formula. What is the formula? We're going to call this one top, and we're going to call this one bottom. So you're going to write derivative of top times bottom minus derivative of bottom times top over bottom is squared. Okay, so I'm going to say it again, and I'm going to ask one student to say it to get the hang of it. So derivative of top times bottom minus derivative of bottom times top over bottom is squared. So who want to say it? Okay, go ahead.
Derivative of y equals to derivative of top times bottom plus derivative of bottom times top over bottom squared.
Almost right. Instead of plus, it is minus. Yeah, everything is right except the minus thing. Okay, all right. Okay, so let's follow the rules. All you need to do, follow the rules. So y prime is equal to okay. So derivative of top. What is the derivative of top using power rule? 2x. 2x times what? 2x times x plus 1. Very good. X plus 1. What should I write? Minus. And then what should I write? 1. Okay. Instead of writing 1 plus 0, now we can kind of like do it at once. Can I write 1 instead of 1 plus 0? 1. And then what? Say it again? X squared. Okay. All you need to do, follow this order. Follow this recipe. And then what? Plus 1 squared. Okay, great. And that's it? Yes. So y prime is what? You distribute that 2x squared plus 2x minus what? X squared over x squared plus 2x plus 1. On the top you can simplify. What you can simplify? 2x squared minus x squared is how much? X squared plus 2x.
3x.
On the bottom, x squared plus 2x plus 1. Please do not cancel x squared plus 2x with x squared plus 2x. That would be illegal things to do. That would be like algebraic crime if there is just what. So if you cancel this and this because they look same, that's no good. Okay, so you can stop here. Does that make sense, the quotient rule? Raise hand if it did not make sense. Since you look less confused. Yeah, wait for like 10 more minutes and then you will be lost. Okay. Hopefully not. And then what else? What is the last one? The chain rule. Oh, okay. I know it's okay. Yes.
Professor, you recording this?
Yes.
You will post it.
Yes, I will post it.
But you leave it like that. 2x squared plus 2x.
I'll show you how to navigate.
I found the first one easily, and the second.
I'll navigate. I'll do it.
You leave it like that. 2x squared plus 2x and minus x squared.
Yeah, you leave it like that. The simplification, you cannot simplify it more. So you leave it like that. Okay, can we move to the next one? Okay. Now, moving to the next one. And moving to the next one is chain rule. Chain rule is, people say chain rule is the most hard one. Okay, chain rule has to do with power. Okay, so like binomial function. Can someone give me an example of binomial function? By the way, binomial function was invented by who? Who? I'll give you a hint. Sir Isaac Newton, right? Okay, so you can. Wow, very good. Yeah. So that was difficult hint, but you use it. Sir Isaac Newton invented binomial function, and binomial function is, this is an example of binomial function. Okay. So once you see the binomial function, you use the chain rule. Why you use the chain rule? You can use this one. You can use the power rule by expanding that, right? But when you see the power is 10 or 20, or then it's almost impossible to use the power rule. This one you can use the power rule. Why? All you need to do, right? X squared plus 2x plus 1 and use the power rule, right? You don't have to use the chain rule. But easy example, when you learn the addition, you learn plus 1 plus 1. That's what I taught my son.
Professor, as it's mentioned your son, you should put your son on the website. He made me feel stupid. Absolutely.
No, he's crazy. Yeah.
He's a genius.
Yeah, he solved. I don't know what he want to solve, but he think he can solve everything. Okay. Why? Okay. So now this is the machine. So I'm gonna ask you to write a bluff, like whatever inside, we don't care. It could be anything. So this is a binomial function, for example, and this is also bluff n. So that means it can be any power and it can be anything inside. It doesn't have to be x plus 1, it can be anything. It doesn't have to be 2, it can be anything. So here is the formula. So y prime is equal to n bluff, whatever is inside, n minus 1 f prime of that bluff. Okay, this is the machine. So y prime, does that make sense, the machine? Okay, let's use the machine.
Is the first one included, or you just give that as an example? Y is equal to x plus 1 squared.
This is, you can solve any binomial problem.
I know, but the binomial already starts from the equation ready for you starts from line 2.
Yes.
Okay. Good.
It starts from line 2, not line 1.
Yeah.
Line 1, not line 1. Okay. Line 2. Y prime. I write y prime. You tell me what to write. Come from here. 2. Okay, I write 2. You tell me what to write.
X.
X plus 1 because our block is x plus 1. And then
2
2 minus 1. And then f prime of
X minus 1. X
x
plus 1.
x plus 1. Does that make sense to everyone? I just follow the rules, and that is the rules. What am I going to do now? Y prime is 2 x plus 1. 2 minus 1 is nothing, and f 2 minus 1 is 1, and f prime of x plus 1 is
X.
no. Derivative of x plus 1 is 1. Does that make sense? If you are not happy, write 1 plus 0. That's also correct, right? Derivative of x is 1 and derivative of 1 is 0. That's okay. Y prime is equal to 2 x plus 1 and 1 plus 0 is okay, 1. So what is the answer? 2x plus 1. If you do use the power rule, you should get the same thing and you should try it at home. So what should you try at home? Y is equal to expand it. If you expand it, what do you get? By using the a plus b square. What do you get? X square plus 2x plus 1. Can you use the definition of derivative to do that? Yes, if you use the definition of derivative, what are you going to get? This one. Okay. So, yeah. Yes.
Why is f prime x plus 1 or x plus 1 squared?
That's from definition. I did not put anything here.
So, if you don't mind me repeating, what goes there?
This?
No, f prime is, what's the power of f prime? Is it n minus 1?
This one? Or this one?
Yeah, that one.
N minus 1.
But then,
This one?
Yeah.
Nothing. Nothing.
so but then y equals x plus 1 squared, you wouldn't bring the square root down for f prime?
No, you don't do that. This is just the rule. This is just the rule.
Professor, I have a question.
Yeah.
In the final answer, it remains in that format or it can be resolved?
Yeah, you can write y prime is equal to 2x plus 2.
Okay, that's what I'm talking
Yeah, it doesn't matter. Either way.
Do you have to take the derivative of 2x plus 2? So like,
No. Stop here. This is the derivative. That's it. That's it. This is the derivative. You stop here. We ask to take the derivative and this is the derivative. That's it. We are not solving a physics problem here. But we're going to solve the physics problem okay. So our goal is to what? Finding P of t. Finding the position function. So any question, we finish the calculus 1. Taking the derivative by limit, taking the derivative by power, taking the derivative by product, taking the derivative by quotient, and taking the derivative by change. Now we're going to do, now this is going to be last 2 days of the class, and which is integration. So integration is the anti-power rule. So integration. So integration, there are 2 types of integration. One is with limit point, no limit point. Okay. There are 2 types. One is limit point and other one is no limit point. So for example, by the way, integration takes you back. Integration takes you back to the past. Okay, you will see in a second what I mean. Do you remember that one we did? Y equal to x squared, right? Okay, you did remember that, and you know the answer. What is the answer for this one? Y prime is 2x, right? So the integration takes you back to the past to allow you to see your to meet Abraham Lincoln. Okay, limit point. So limit point is when you have the limit on the bottom and limit on the top. For example, this one is 0 and this one is say 2. Okay, and write 2x dx. Now antiderivative, the formula of antiderivative is this. The formula for this one is y equal to xn. Can someone tell me the power rule? Y prime is equal to n. That's it, right? Okay. Now we're gonna know the anti-power rule. Anti-power rule is y equal to xn. Y prime, y not y prime by the way. Integral xn. Say it again. Say it again.
No, I was asking if you can write it on the other border.
Oh yeah, sure.
So it's not so close.
That's right. That's right. So integration. So limit point, limit and no limit. No limit. Limit is so 0 to 2, and this is 2x dx, and no limit point means just 2x dx. That means the area under the curve between 0 to 2. And area under the curve is just, there is no limit given. Okay, so let's do this one. But before we do this one, so power rule, as you said, this is the power and this is the anti-power. Anti-power. So power, you told me x raised to n is y prime is equal to? Okay, now I tell you x n, when you do the anti-power rule, so xn is x n plus 1 divided by n plus 1. So instead of writing minus, you write plus. So, and you divide by power. Yeah, you divide by exponent, you divide by power. So this is the simple rule. And we're going to apply this simple rule now.
Professor, let me repeat it.
Yeah.
Okay.
Okay. Ready? Where is my tea or coffee? Oh, thank you. It's actually coffee. Can I erase it? Okay, so anti-power rule. So this is power and anti-power. We will do it again. Y equal to x squared. Power rule. Can you allow me? Can you help me take the derivative? 2x 2 minus 1. So y prime is 2x. Okay, great. That's true. That's a true statement. Now, can you help me find 2x? So this is 2x, right? Can you help me go back? Go back. We're gonna go back. So we're gonna write 2x and dx. Dx asks us to go back. Go back to where you come from, or go back to the position function, because this is your position function. In physics, because everything is physics, because calculus was invented to solve the physics problem, once again, just to remind you, so this is a position function. Position function. If this is a position function, this is what? It's a velocity. Velocity. You can take one more derivative, that would be acceleration. You know what is velocity is, right?
Mm-hmm.
What is it? Speed. Speed. So how the position gives us the speed through the calculus? Something magical, very, very magical. Okay. Okay, let's do the anti-power rule. First do it by limit point, and then do it by no limit point. Limit point. So anti-power. So write 2x and write 1, and you said 2, right? Okay, great. So 2x, no, this one, just do it without no limit, and this one limit. 0 to 2. Okay, how can we do that? So we're gonna write 1 over here, obviously.
1 plus 1 divided by
So 2x 1 plus 1 divided by 2, very good, plus c, because there is no limit point, that's why you have to write c. Remind the audience that you don't have limit point, that's why you write c here. Does that make sense?
Isn't C for a constant?
Because it would be the same if you were looking at it before and
That's right.
plus C,
Yeah.
correct?
Yeah. So what do you get? 2 cancel, what do you get? Y equal to x squared plus that c. Is that what you started from? Yeah. Is y equal to x squared, y equal to x squared. Does that make sense?
The plus C is for me.
The plus c in this case is 0. Yeah,
It's because you lose information when you take the derivative.
that's right. When you lose information, take the derivative. No, you don't lose the information.
Well, but you lose the
You lose unimportant, not important information.
Okay.
Yes, you lose not important information. For example, what is not so important information here?
Direction.
Plus c. A number. Why the number is not so important? Because x squared plus 2 is, the derivative is 2x. X squared plus 3 is 2x. X squared plus 2 trillion is 2x. Does that make sense? So that was I was thinking. So did I answer your question?
Yeah.
So you lose the information not so important because this information is not important. The constant is not important because when you take the derivative, the constant is always 0.
0. Okay,
Yeah.
that answers my question.
Yeah.
Because the derivative of the constant is always 0.
Yes,
Okay.
the derivative of constant is 0.
No,
So
no,
this
no.
guy is gonna become 0 anyway.
Okay.
This guy gonna become 0 anyway.
Now I get it. Okay.
So just this convention to write C to remind people that there was no
Constant.
limit point. There was no
No limit.
limit point.
Okay.
Just to remind. Okay. So now with the limit point, let's see what happened with the limit point. Let's see what happened. So what are we gonna do? We're gonna do the same thing. So 2, we're gonna write 1 here. 2, 1 plus 1 divided by
2.
2. Then we're gonna write 0 and 1 because there is a limit point, right? 0 and 1. Oh, 2. 0 and 2. Does that make sense to everyone? So now 2 cancel, right? So now x squared 0 2, right? X squared 0 2, right? Does that part make sense?
Yeah.
So now x squared. So what is x? 2 squared minus 2 minus 0 2. So this is 4. So area under the curve is 4 in this case. Yeah.
So always minus? Is
Always minus, yes. Always minus. Okay. I gave you some background. This is like last 2 days of the class. It's gonna be like this in May 15, maybe. Oh, there is no May 15. Like May 2 or 3. We're gonna touch on this again. Now we're gonna do that. This is, so let's make a convention. This is no way 80 feet above the ground. Let's say this is 80 feet above the ground. My table is 80 feet above the ground. Does that make sense? We're gonna make this convention. Is that okay to make this convention? Okay. So now what I'm gonna do, I'm gonna go over here and I'm gonna throw this apple. So I'm gonna throw this apple right here. So in order to throw this apple, how can I throw this apple? I can't. Why I cannot throw this apple? So I am my apple is 80 feet above the ground. Does that part make sense? This is 80 feet above the ground. So if I throw the apple, what I have to do? So I have to. Okay, I have to. Someone said that. What is the word? Force. I have to apply some force. I have to apply some force because the velocity is the function of force. So I have to apply some force. The velocity, the speed, is the function of force. No force, no velocity. Zero force, zero velocity. In order to get the velocity, in order to get it moved, in order to make something move, you have to apply force. So I'm going to apply force. Let's say I'm going to apply 64 feet per second. Write it down. 64 feet per second. All right. So who can take a catch? Who is good in catch? You take some risk though. Okay. So who want to take a catch? All right. So still you want to take risk? Okay. But you can take apple home. Okay. So you still want to take a risk? Okay. All right. You take it home. Okay. Very good. Okay. So, yeah. Throw or three, it doesn't matter. Throw an apple. Okay. Throw an apple from 80. Did I say 80 or did I say something else? 80 feet above the table. 80 feet. So Professor Barry threw an apple from the top of his tower, which is 80 feet, which is 80 feet above the ground. So Professor Barry threw an apple with how much I said? 64 feet per second from the top of his table, which is 80 feet above the ground. How much time the apple was in the air? What's your name, sir? Devan? How do you spell that?
D-E-V-O-N.
Okay, so how much time the apple was in the air? How can I phrase it differently? How much find the elapsed time between find elapsed time between the moment it left my hand and the moment they caught it. Okay, find the elapsed time between
The apple stay on air.
yeah, that's what I wrote before. How long the apple was in the air. So find elapsed time between it left my hand. It left my hand and till DEV1. Got it. This is number one. Find the elapsed time. Number two, find the velocity function. Velocity function. Number three, find acceleration function. Acceleration function. Number four, find instantaneous velocity. Instantaneous velocity. When t is, let's say, I don't know, let's say 2 seconds. T is 2 seconds. Find the instantaneous acceleration when t is 2 seconds. Number 5. Find instantaneous acceleration when t is 2 seconds. Okay. All right. Can someone summarize the demonstration that you saw? I did. I went up to table, which is 80 meters above the ground. I threw an apple using 64 feet per second, and there was some elapsed time between two hands. And all you need to find is very simple thing. How long the ball was in the air, how long the apple was in the air, and then what? The apple, how long the apple was in the air, and then you have to find the velocity function, the acceleration function. In instantaneous velocity, when the time was 2 seconds. Instantaneous velocity when the time was 2 seconds. That means when the apple was, what's your name, sir? No, your name. Emmanuel. When the apple was, okay, apple is in divine hand. So when, in order to go to divine hand, the apple had to be, this apple had to fly, right? So at one time, the apple was above his head, right? So 2 seconds maybe, at 2 seconds, probably apple was above his head. Does that make sense? Or above her head, or above his head. It doesn't matter. Does that make sense? We have to find that instantaneous velocity and then instantaneous acceleration. Thing called quadratic equation. Yeah. How many years have you been seeing quadratic equation? For a long time, since grade school or since first grade, second grade. Okay. And now, how many years you've seen something like falling, something you throw something, something like you see something falling? How many years have you been seeing it? Like since your childhood, right? When you see something falling, you throw something. That is quadratic equation, and that's what we're gonna kind of rediscover. What Newton discovered, we're gonna rediscover it today, and that will give us some understanding. Everything around us is physics. Okay. Now the first thing, I'm gonna draw my table. So draw my table. Here is my table, and here is me. Here is me. So this distance is, we don't measuring it. We kind of agree that this is 80 feet. 80 feet. So what are we going to call that? We're going to call that distance is 80 feet. Does that make sense? We can call it distance, but we're going to change the language in a second. All right. And then we say the velocity instead. In order to put something, in order to let it go, this apple, let it go. The velocity was how much? 64, right? Or 60 something? 64 feet per second. 64 feet per second. Okay. So we just use velocity. We just use d. We are using something that convenient for us, and we're gonna in a second we're gonna change the language. And then something we kind of know that acceleration due to gravity. Acceleration, when you let something go here on the earth, it falls. It falls because yes.
Would the acceleration of gravity be 9.81 meters?
9.8 meter per second squared. It's always 9.8 here, as long as you are talking about very close to surface of Earth. Yes, 9.8. Negative 9.8. Yes, it's constant. It's constant unless you are talking about the summit of Mount Everest. If you go all the way to the Mount Everest, it's like not 9.8. It's like 9.7.8. It's less than 9.8. The further away you are from the center of the earth, if you are here, we are here, right? We are here, right? If this is center of the earth, we are here, right? And this is the Mount Everest. Well, not that far, that much. Here is Mount Everest. So the Mount Everest is really much away from the center of the earth than the Bronx Community College, right? Yeah. Okay. So if you go to even here, if you are flying, then it's gonna be 9.7999. It's very close to 9.8. That's what I'm trying to say. So we're gonna let it 9.8. So acceleration due to gravity is 9.8 meter per second squared. We're gonna convert it to the feet per second so that we can use feet per second. Okay, now let's do the conversion. So negative 9.8 meter per second squared times, what do we want to have? Meter per second. We want to cancel the meter. So 1 meter is a square. 1 meter is how many feet? 3.28 feet. And that meter cancel. 9.8 times 3.28 is how much? It's 30, 31, 32, sorry. 32. Okay, so negative 32. We're gonna round it to the whole number. Negative 32 feet per second square. Does that make sense? So this is the acceleration due to gravity is negative 32 feet per second square, which is equivalent to 9.8. Does that make sense to everyone? Okay. Now we're gonna use the same language. We're gonna write. This one is our position function. Why it is position function? I'm here, so this is my position. So that makes sense, right? So it's my position function. So I'm gonna write, everything is function of time. So I'm gonna write P of t. P of t is 80. Is it okay if I do that? Because this is my position, that's why I wrote it, right? So now I'm gonna, instead of P of t, I'm gonna call it S of t. In physics, you call it P of t, and here I'm gonna call S of t. Does that make sense? Instead of P, I'm going to call it S of t. That's its position. Okay. In physics, this is called V of t, the velocity, 64. In math, this is the first derivative. This is the velocity is what derivative? The first derivative. So in order to get first derivative, I have to put what? Prime. Very good. As t is what? Can someone tell me? What is that? No, 64. Does that make sense? It's already velocity, right? And velocity, I'm using the same language. Instead of writing, okay, I'm going to make it easy. I'm going to write d. And then I'm going to write P of t. And I'm going to write S of t. And then I'm going to write finally 64. That makes even a little bit better. That looks a little bit better, right? That means this is equivalent to this, this is equivalent to this, this is equivalent to, everything is 64, right? This is what? Velocity. Velocity is function of what? Time. And instead of velocity, velocity is in math, what is it? Fast derivative, fast derivative. So instead of V of t, we're going to call it S prime of t. So what is velocity is still velocity is still velocity. This is still velocity. Another name of fast derivative is velocity. Another name of fast derivative is velocity. There is another name of fast derivative, and that is velocity. Yes.
Isn't the first S of t 80?
Oh, okay. Position is 80. Very good.
Thank you.
Very good. Very good. So what is the velocity? 64. Very good. Now, one piece of the information we're going to add, and that is what? Acceleration. Acceleration is also a function of time. However, in math, what do you call it? Second derivative. So as double prime of t. As double prime of t is how much? Negative 32. If you understand this one, then we can move to the next part. But this part is important because this will allow us to read the mind of God. Because we're going to go backward and we're going to try to understand why something falling, why is something throwing, and what is happening around us. And that is reading the mind of God using calculus. Did you understand? Raise hand if you did not understand, because you will not be excited if you don't understand this one. Raise hand if you don't understand this one.
I need food.
Okay. Now raise hand if you do understand it 100%. You do understand it 100%?
Not 100, but like you see how you put D, V, and A. Those are the physics terms, and I kind of remember them from high school when I went for this.
Okay. Okay. So who understand it like 100%? You understand it 100%? So why don't you explain?
So the distance is position of time itself.
Distance. Okay. All right.
That's a. So then, if you take a first derivative of that, then you get the velocity, which is equivalent to s prime, or you can write down s prime t. So then, if you take another derivative of s prime, then you're gonna get acceleration.
Very good. Very good. Now I'm gonna write it. He said, this is position, and when you take the first derivative of position, you get velocity. When you take the second derivative of position, or you take one more derivative, you get acceleration. That's what he said. Is that what you said? Okay. Is there anyone can explain it something using different word, different way? Some people can explain it really, really easy, and that really, really make our life super excited. Yes.
The regular position is 80.
Okay. Position is 80. Okay.
If you take the derivative of 80, you're gonna give you the position. Sorry, you're gonna give you the velocity. That's
Not the case here. Yes, that could have been the case, but that is not the case here. Yes, everything is given. Everything you saw happened. We cannot reinvent anything. Everything happened. We cannot change the position because that is 80 meter above 80 feet above the ground. We cannot change 64. Why not? Because that much force I have to apply to throw it to Devang. We cannot change 9.8. Why we cannot? Because that's the acceleration. We cannot change anything. With this information, we have to find those. How long the ball was in the air, the velocity function, the accelerator function, the instantaneous velocity at when the time was 2, and then the instantaneous acceleration when the time was 2. Okay. Yes.
All right. Quick question.
Yeah.
V stands for velocity. A stands for acceleration. What does D stand for, and what does ST stand for?
D stands for anybody? Position
D is
or distance.
which is PT.
PT.
And what is ST?
ST?
What does that stand for?
ST in math, instead of position, instead of using PT, you call it ST. So that you can use the common language. Is this a common language to you? No. This is P, this is B, this is A. Is this a common language? No. Is this a common language? Yes. S prime, S double prime. This seems to be a common language, right? So, this language, if you like that, is okay. If you like this, is okay. If you like this, is okay. How many ways of understanding this thing? 3 ways. 1, 2, 3. Whatever way you want to understand it. Okay. I want to see one more hand, and then before we move on. No hand? Can we move on to the next one? Okay. Yeah? Yeah, sure. Acceleration. Yes. What's wrong with acceleration?
I don't know how to calculate the acceleration.
Oh, this one? Okay. 1 meter. This is equal to 1 meter. This 1 meter is like a meter stick from here to here, right? So this is equivalent to 3.28 feet. So 1 meter is how long? 3.28 feet. Does that make sense? Yeah. Right? So say I am 5 feet. I'm 5 feet. Okay. So someone is 6. Is there anybody here 6 feet? Oh, 6 feet. Instead of writing 6 feet, what can I write? In inch. What can I write? 72 what? So these two are equivalent statement. Does that make sense? Okay. No problem. Okay. So can I move to the next part? Okay, next part is the part with S prime of t. That's our goal. We're gonna go backward. Because our goal is to find what? Our goal is to find position function. Forget about everything else. Once you find the position function, everything is easy. I threw an apple at Devang and Devang caught it. You have to find the position function. You saw the demonstration. The demonstration was someone throw an apple at someone. Find the position function. And the position function is our goal. So how can we do that? We're going to walk backward. We're going to start from here. Okay. So from here to here, what do you call that one? As double prime of t. So our goal is to move to 2 steps at a time or 1 step at a time? 1 step at a time. Okay. So we're going to write our goal is S prime of t. S prime of t using what? Using what? S double prime of t. From here to here, one step at a time. Not jumping, one step at a time. So S double prime of t. From here to go to here. And then we accomplish something, and then we'll accomplish something, and then we accomplish something. At the end of the day, we'll have something look like we've been saying for many years. So S prime of t, what is the S double prime of t? Anybody? Huh? Negative 32. Negative 32 what? dt, because this is the function of time. This is the function of time. So we're going to use dt instead of dx. Does that make sense?
Yeah.
Okay. So now what are you going to do? We're going to write s prime of t is equal to negative 32 t divided by what? Divided by 1, because there is a power 1. Okay, before I go further, I want to give you some hint. Y is equal to 2. What is y prime? 0. Y is equal to 2. What is the integral of that? 2? 2x or 2t? Yeah, very good. Does that make sense to everyone? Because if you take the derivative of 2t, what do you get? Right? We can agree on that? Okay. It's okay. This you saw it first time. Okay. So can we put t here? And if you divide by power of t, dividing by 1 doesn't make any difference. Plus, is there any limit? No limit. So you're gonna write c1. C1. Okay. All right. Did you find from the acceleration? You found what? You accomplished one thing. You found the velocity. From acceleration, you found the velocity. That's amazing, right? From acceleration, you found the velocity. Okay. You have to find c, by the way. Okay. When I was okay, so let's find c. S prime of t. Okay. When I was here with the apple on my hand, before I throw it, what was the velocity?
0.
Okay.
No,
The-
we had a constant of this.
The moment I started, the moment I apply the force, what was the initial velocity?
64.
64. So that's what we have to find. So St is equal to, when t was 0, I apply 64 when t was 0, right? Does that make sense? So when t was 0, I apply some force, and that was how much? 64. Okay. So then this is c1, right? Okay. So you're gonna go back here. You're gonna write s prime of t is equal to negative 32 t plus 64. Did you understand this argument? Did you understand this argument? This is logic to reading the nature, the what happening in the nature. Did you understand the logic? Okay, you understood the logic. Okay, great. Now we have to do. Now we are here. Now we have to go where? The final stage. So we are gonna write st and then s prime t. Right? 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 Because this is our goal to get it. Okay, so now let me erase this one. So what are we going to write? St, interval sign. What is s prime of t? Anybody knows? Negative 32t plus 64 dt. Now we're going to integrate it. So can someone help me integrate it? So say it loud.
Minus 32
Minus 32, what happened?
over
Now,
T squared
t squared.
over 2
Very good.
over 2.
plus 64 T
Plus 64t. And then?
over 1.
Okay, over 1, I can ignore that. Okay. Plus c2. Good. Does that setup make sense?
What was wrong with what I said?
You did not say square.
No, over 2 first. Because I applied rule n plus 1.
Then I did not hear it.
Oh, okay.
Okay, okay.
I don't know where you got that. You lost it.
Where?
Right there, that part.
This part or this part?
That whole line.
Okay, the whole line was y is equal to xn, right? y is equal to x n plus 1 divided by n plus 1. Okay, so this comes from there. Okay, yeah, everyone here? Okay, so now what are you going to do? S of t is equal to 16 negative 16t squared plus 64t plus c2. Now when I was on the table, what happened? What was my position? Huh? 80, okay. So what is my c2? So my c2 is, when t was 0, what was my position?
80.
So t is 0, so 80. So now we're going to put everything together. So s of t is equal to, s of t is equal to? 80. So we're going to put everything together. So negative 16t squared plus what? 64t plus 80. Okay, now this is going to allow us to find, now we're going to start solving the problem. How long the apple was in the air? Now we're going to solve everything. So we found the function. From the simple demonstration, I threw a ball at the one, and that allows us to find the quadratic function. So this is the quadratic function. It's built in calculus. So now you're going to find, they're never going to ask you to find the quadratic equation. Right? They're going to give you the equation, and they're going to ask you to take the derivative, do this, do that. So your job is easy. Whatever you're going to be doing, whatever I'm going to be doing next 10 minutes is what you have to do. Whatever I did last 30 minutes, you don't have to. You never have to do that. Especially in the math class. That's not. But that allow you to kind of, I hope, excite you to see behind the scene. Behind the scene. Okay, so now we have to find how long the ball was in the air. So S of t is how much? Negative 16t squared plus 64t plus 70. Okay. Plus 80, yeah. Plus 80, okay. How long the ball was in the air? How can you do that? Anybody? Any good approach? This should be easy now. How can we find it? Solve for t, very good, solve for t. So, there are two ways to do it. You want to use the quadratic formula, minus b plus minus b square minus 4ac over 2a. So a is, why you don't factor out 16? Okay, 16, factor out 16. So minus t squared plus what?
14.
Plus
14.
4 t plus 5, I guess 5. So if you set it to the 0 and divide both sides by 16, then you get t minus t squared plus 4t plus 5. Is there any problem with that? Is there any problem with that? No or yes? We can do that, right?
No, it cannot be negative.
Well, we did not factor out negative. We just factor out 16. We did not want to, because for some good reason, we did not want to change the negative. If you change the negative, math is same, but physics is not same. Math is same, but physics is not same. That's why we refuse to factor out negative. You could have factored out negative 16. Your math is still same, but not physics. Okay, now what are you going to do? Now is easy. Now you don't have to use the quadratic function. You can use anything you want. Minus t squared plus 5t minus t plus 5 is equal to 0. Is that okay?
Plus 40.
Is that okay?
Yeah.
Plus 5.
Yeah.
It's okay, right? So what is the common factor? Minus t is the common factor. So if you factor at minus t, what do you get? T minus 5. Minus 1 is the common factor.
Okay,
T minus 5 is equal to 0. So you have t minus 5 and you have minus t minus 1. Okay. Okay, so t minus 5 is 0 and minus t minus 1 is equal to 0. So minus t is equal to
Negative.
1. So t is equal to negative 1. And we call it extraneous root. We call it extraneous root. Why? Because the physics doesn't allow us to go back to the time. Not today. Maybe tomorrow. Maybe someday in the future. But we cannot go back to the time yet. Not yet. So that's why, what do you call it? Extraneous root. So how long the ball was in the air?
5 seconds.
The ball was in the air 5 seconds. So by the time the up ball left my hand and touches the one hand, what was the elapsed time? 5 seconds. In the middle of that 5 seconds, 0 second to 5 seconds, lots of things happen. If it was instead of up ball, it could have been what? A missile that carries the nuclear weapon. Does that make sense? It could have been a missile that carries the nuclear weapon. Does that make sense? And still you do this calculation. So all of a sudden, it becomes important, right? Instead of apple, if it is missile, then it becomes very important and you don't want it falling in the middle, right? So that's why initial velocity, everything is all of a sudden become important. Does that make sense? Okay. So at 2 seconds, it was on whose head? Over whose head? That's what we're going to find out. Let's see. Okay, what is the next thing we have to find? Not acceleration function. We found the elapsed time. What was the elapsed time? 5 seconds. Find the velocity function. Okay, how can we find the velocity function? Anybody? S is equal to t is equal to negative t squared, negative 16t squared plus 64t plus 80. How can we find the velocity function? Anybody? Take the first derivative. So s prime of t. Should we use the limit? No, we don't want to use the limit. We're just gonna do as soon as possible. What is it? If we use the power rule, product rule, quotient rule, or chain rule, which one are we gonna use? Power rule, right? So if you do use the power rule, what do you get? Help me out. I need help.
Minus 16 multiplied by
Minus 2, okay. 16 t 2 minus 1, okay. And then what are we gonna do? 1 64 t 1 minus 1 plus 0. Okay, is that okay with everyone? Yeah. Okay. So s prime of t is what? Negative 32 what? Negative 32 what? T plus 64 t raised to 0 is 64, right? That's it. That's what we saw it before, right? Yeah. Somewhere we saw it before, right? Did I erase it? Yeah. Probably I erased it, but it's somewhere there. So we saw it before. So we went backward to go backward and then go. Now we are moving forward and seeing what we saw before. Okay. Now this is what function? Velocity? Velocity function. Now the next question asks us to find what? Acceleration function. So acceleration function is what? Can someone tell me? So now what is it? Huh? Oh, very good. Minus 32, okay. Minus 32 what? That's it, right? did you see that number before? At the very beginning of our whatever. Yes, you saw it before, right? Okay, now you got it again. Okay. Now, what are we going to do? We're going to solve what problem? Find the instantaneous velocity. How are we going to find the instantaneous velocity when time was 2 seconds? So, S prime of 2 or S double prime of 2? S prime of 2, which one are we going to plug it in? S prime. S prime. S double prime is something else. So S prime of 2 gives us what? Instantaneous velocity. So what is the instantaneous velocity? Anybody?
Negative 32 times 2
Plus
62.
So instantaneous velocity at 2 seconds was 0. Okay, what does that mean? Anybody? That is very interesting in physics. Yeah. Yes, very interesting.
You didn't throw it that time. You didn't. It was in your hand. You were just carrying motion that time.
No. Okay. Anybody? This is powerful. This is the powerful moment of why the velocity. What was the position when the velocity is 0? Put it that way. I give you a hint. What was the position? Okay. From me to Devang, how many men sitting diagonally or women? Okay, like 3, and there is an empty seat. Okay, so at what position? Was it here when the velocity was 0? Was it here when the velocity is 0? No. Was it here when the velocity is 0?
No.
Was it here when the velocity is 0?
No.
Is this kind of middle from me to here? Okay, great. Alright, so what that has to do with that?
That kind of means that what the velocity was, it was on your.
I'll give you more hint.
Oh, okay.
I throw a marker. What do you expect? The marker will go up and hit this guy?
No.
And it come back.
It was in the high point that time.
At the highest point, the velocity is 0. Why the velocity has to be 0? If you can find a way not making velocity 0, then what happened with this marker? It will never fall. It will never come back. So I throw an apple to him. It was a parabola, right? At some moment of the time, the velocity had to be 0. Otherwise, the apple would never fall. Apple would go up and go forever to the sky, hitting something in the sky. Does that make sense? So when you throw something falls is because at some position of the time, the velocity is 0. Is because the marker changes the direction. So in order to change the direction, you have to stop for how many seconds? A fraction of a moment. Does that make sense? In order to change. So that's why they call it vortex. So this is a good moment to understand the vortex. Vortex is a point where the velocity is 0, where the ball or apple changes the direction. Does that make sense? Or highest point. Okay, so highest point is equal to what? Why I stood up over there to kind of demonstrate something so that make you excited. Because it always in the middle. The vortex or the peak or the highest point is always in the middle. She is not in the middle between me and Devang, right? So what is in the middle between me and Devang? That empty chair, right? So right above the empty chair, the velocity was 0. Does that make sense? That means the apple was changing the direction, and for a fraction of a time, the velocity was 0. Does that make sense? Okay. All right. So that is big thing. That is a big thing. Okay. Now acceleration. You're going to find the acceleration at 2 seconds. I had no idea that 2 seconds it changes the direction. It's just a coincidence. So what is the acceleration? Huh? Yeah, at 2 seconds, what is the instantaneous acceleration? 32. It never changes. Yes. Why it never changes? If you plug in 2 over here, because there is no variable, you cannot plug in, so it remains 32. Does that make sense? Okay, so if you owe me lots of things, if you give me those things, that would be fine. And otherwise, you can go home.